Let's go beyond the connection. Welcome to the podcast. I'm Steve McDonald, your host. And today we have a very special preview. We have the founder of Bigleaf Networks, Joel Mulkey. And Joel, you and I are going to be talking about a lot, but in terms of kind of a focus, we all live in a world of AI, and we at least know the vision of how it's going to revolutionize everything we do, but especially in the world of internet connections and our corporate networks and resiliency and things like that. We're going to be talking a lot today about supercharging AI with our networks and how important that part is, and the role of fiber and wireless and how all of this mixes together to produce the best result. And so what I'd love to do, though, is other than the fact that you're the founder of Bigleaf Networks, you also are a technologist at heart. The focus on people in technology and throughout your whole life is a big part of what makes Joel. And I think one of your proudest moments is probably being Chief Dad Officer, the CDO.
Yeah, I think top priorities in life for me, my wife, my relationship with God first, wife second, and my kids third. Everything else is pretty secondary, but I do care a ton about the people that have been a part of the businesses I've had the opportunity to be involved in, Bigleaf being the biggest success of any of them, and a story I like to talk about.
Tell us, maybe start us out with the founding story of Bigleaf and why you founded it and what you were hoping to accomplish.
Yeah, I've always been an entrepreneur at heart, from mowing lawns when I was 10 and running around the neighborhood trying to earn a little bit of money to dabbling in different business ideas. Eventually, I ended up a part of a fixed wireless ISP that was basically a startup, not venture-backed, but a bootstrap local company, and got the opportunity to be there on day one through quite a while. I think it was about 10 years, my time there. And during that time, I saw some things that were great about building a business, and I saw some things I'd want to do differently. And so in 2011, I said, hey, time for me to step outside the nest and go build a business full time. And I was kind of trying to figure out what to do and how to go about all that. Read some good books, Dave Ramsey's EntreLeadership, read that one and got some good principles from that. And one of them was build a business that you can get shouting excited about. So you could stand on stage and say, you need this, customer. It's going to change your life. And I made a list of what are things I could get that excited about. And the geek that I am, internet redundancy was one of those things. And there's not a ton of people, I think, that can get shouting excited about internet redundancy. But the business FreeWire, that was the ISP I was a part of, I kept regularly seeing customers who would try to implement some form of redundancy, a cable circuit and a wireless connection, or fiber or wireless, and run into problems when they tried to integrate those together. And that peaked at a point where I went to this church service I was a part of. I was actually running sound for. And we had an internet outage. Comcast went down, and it was mayhem. Like you couldn't check kids in because the tracking system for if your kids checked in for their class was down because it was in the cloud. And we couldn't stream a video we wanted to stream and put up on the screens. And so the next week I went to the church's IT director and I said, hey, let me give you a free wireless backup internet connection with this fixed wireless company I was a part of. And then I'll help you integrate it together with the Comcast for free. But no questions asked, just put it in, do it all for free. And he told me no. And I left that meeting in shock. He basically said, hey, we've already tried to do redundancy. We had Cisco experts configure a router, and it just doesn't work. And I realized as I was driving away from that meeting, I knew what I was dreaming of could be built and would work without questions. And it would be like plug and play. Users wouldn't have to do a bunch of Cisco config and stuff. And that gave me the conviction, okay, I need to start this company, which turned into Bigleaf. And away we went. That was tail end of 2011 and led to a long journey of building a business we'd be happy to talk more about.
Absolutely. And you said something in there that's it's a term that's used that it almost then becomes meaningless, like the words like value and things like that, plug and play. Like everybody says plug and play. I've had the good fortune of talking to a lot of your partners and a lot of your customers, and they literally do things like this. I plug it in, and it's amazing what happens to the network. I unplug it, and it all goes back to chaos. And it's that easy to plug and play out. So I definitely want to explore that a little bit. But I'd love to have you maybe tell us a little bit about the fundamentals of how Bigleaf works so that we can just understand that.
Yeah. One of the key sort of to that plug and play notion, key convictions I had was Bigleaf needed to do everything we said it would do for all the users' traffic all the time. The issue with prior technologies, BGP routers, load balancers, firewalls, all that, is they have a button that says failover or redundancy. They have dual WAN, this and that, but they only work in certain kind of lab scenarios where, oh, this type of traffic will fail over and this one won't. Oh, this is how we detect traffic, and that issue is further out on the internet. We didn't detect it, so it didn't reroute, et cetera. And so to solve all that and get rid of those whole sets of problems, Bigleaf chose a new architecture. We said, okay, let's have a device at the user location. And let's have our platform out in what you can think of as the cloud, maybe data centers where we put it infrastructure. And between those, create tunnels and send traffic through those tunnels that we control. So our software can detect problems along that whole internet path end to end and move the traffic around in real time with the user not even noticing, because their IP addressing doesn't change. We don't have to change anything about the traffic other than which of the tunnels it goes down. And there's complexities to that, making sure packets aren't reordered and traffic's not bouncing around and other weird things. But really a fundamentally different way of using the internet to bypass these sets of problems that existed with the prior technologies.
One of the things that is in the middle of all of that, that even today, the story you told, I love that you made that offer to your church and you were turned down, which that's amazing. But there still is lingering perceptions today that anything wireless is not as good as fixed. And I'd love to give you the opportunity to address that perception head on here.
Yeah, it's been interesting along our journey building and scaling Bigleaf, how many times we've had to run into really smart, savvy engineers and others in the networking space that said, no, that doesn't work. That's impossible. The original, oh, you can just unplug one of your wireless connections and traffic will fail over on a voice over IP call with no user interruption. People just didn't believe that. They knew the old technologies and say, oh, that won't work. And some of the usage of wireless is the same way. You might say, oh, we can't run critical video conferencing over a 5G circuit or over low Earth orbit satellite or something like that. And yes, with traditional networking, it's unwise to do that. Wireless connections are much more variable than fiber. Now, when you start comparing with other commodity landline connections like cable or DSL, now you're in equal territory a lot of the time as far as performance and quality. But if you compare fiber against wireless, you do have to have some additional intelligence applied to the network to get a good user experience. So what we found when building Bigleaf's wireless functionality is we have to monitor the circuit pretty aggressively, and we have to adapt in real time as the health and performance of that circuit varies. That's things like packet loss, which you see a lot of on Starlink low Earth orbit satellite, jitter, which is pretty common in cellular networks, 4G, 5G. And so if you just blindly put traffic on those paths and say, that's my internet, yeah, you're going to have a variable experience. You're going to have some days that are great and some days where users are calling upset. So with a platform like Bigleaf, what we built from the ground up, because we built it in that fixed wireless ISP environment that I was working in at the time, it was, hey, let's detect the quality of each path in real time, 10 times a second, and adapt to that, keeping traffic where it needs to be to give a good user experience. Not on some fixed set of rules like old school firewalls. Oh, I want this traffic here and this one here, and some user has to change that, but rather using smart software to adapt that in real time.
The idea is that I'd love to talk about the changes even from when you first founded the business, because today the need for a wireless network infrastructure isn't what it was before. I talked to one of the guests on this podcast who put in an HVAC system in an airport, and he said, it's all wireless nodes. There's no way we can connect. Just the physical impossibility of having a wired network in today's business infrastructure, and the need that we have to have wireless. So we have to figure out a intelligent wireless solution like you're talking about. I'd love just to hear the evolution, even since the beginning, the founding of the business to where we are today, and the need for wireless as a part of our network infrastructure and how that's changed.
Yeah, I think two big changes come to mind. One is the IoT use case, which you described in an airport or HVAC, those sorts of deployments where you have a lot of devices, very low bandwidth. running cabling to them is impractical, if not impossible. And there's RF waves all over the air that they can talk via the water meter reading with some of the really low frequency, low power wireless to 5G IoT devices. It's amazing the proliferation of wireless connectivity and what that's enabled, where I can go on my utilities website and look at the power usage for my house hourly because of that sort of technology. And then I think in the Bigleaf case, using wireless for broadband connectivity into an enterprise network or a branch location or a retail location, that sort of thing. One of the bigger shifts that I've seen is the higher capacity urban deployments, where in the past, wireless, speaking specifically 4G LTE, was very much a lower to moderate bandwidth compromise solution. Okay, we can't get anything else and we need to deploy really quickly. Let's put this in. And nowadays with 5G and some of the higher frequency, ultra wideband, or even C-band stuff out there, you can get a lot of throughput and very impressive latency loss and jitter performance from an entirely wireless circuit. And those can be a long-term, if not sole circuit, then a primary, definitely in the mix in load balancing with a product like Bigleaf, just not something you would really consider back 5-10 years ago. So that's been an impressive shift. I think out in more rural areas, you do see throughputs and performance that are a little bit more of that 4G LTE style or class. And so that can nicely mix with low Earth orbit satellite. Is actually what I'm talking to you over at home here. I have Starlink and I have a quote unquote 5G wireless connection from Verizon. Now, the 5G is a label. It's not super fast, but it works great because it has much less packet loss than the Starlink does. So the Bigleaf system is able to detect all that in real time, put critical traffic over the cellular connection as long as it's healthier, and put the higher throughput needs, downloading a file, that sort of thing, over the Starlink connection and adjust as needed.
So you just brought up something really important, is the intelligence to understand what the priorities are on the network automatically. If maybe explain that just a little bit more.
Yeah, and this is one of the weird things, weird in a good way, about Bigleaf. So in most traditional networking devices and systems, an administrator has to go in and manually identify traffic, or there's categories of traffic. This is all web browsing, google.com, yahoo.com, linkedin.com. It's very explicit identification of traffic and then rules to say what those should do. With Bigleaf, we tried to build it a little more adaptive and maintainable, such that we're looking at traffic patterns and behavior rather than explicit rules of this is this application. Now, in some cases, there are those explicit rules, and there's power for users and admins in our support team to add those explicit rules as desired. However, even if those don't exist, the technology and the software is able to say, hey, oh, that's interactive traffic. Someone's interacting with a tool, a website. It needs to be prioritized above this bulk data flow that is just someone moving a big file back and forth.
So the intelligence that you're talking about actually extends. You've built it as a platform that almost could have like additional like SaaS products put on top of it. You built it for capabilities that aren't there yet, or a vision of what could come. I didn't do it justice. I'd love to hear your vision of what that is and future-proofing Bigleaf to basically enable what's coming too.
Yeah, I think it comes out of the flaws I saw in legacy products that were all rules-based. Of an administrator has to go in and create these rules and maintain them. If 3 months later, Microsoft changes how they implement Teams and it's a new port number or something, does the network technology detect that properly? Or does there have to be a software update, or does a user have to go change something? All that seemed unacceptable to me. It seemed like, well, why can't we match on information that is more intelligent, than that's able to discern what the user's trying to do, less so focused on what specific website are they visiting, that sort of a thing. With the goal being get more maintainability, users spending less time having to do things that don't add value to the business, and a better user experience. At the end of the day, when the VP of sales is on a call, they don't care about what rules are in the load balancer or the SD-WAN device. They care if their call sounds good and if it looks good.
I want to go more to the experience. And one of the biggest trends these days is how AI is working in this kind of an environment, but also how Big Leaf and this kind of a resilient, kind of unbreakable network connection, what does that mean for the future of AI? And as a business, how our reliance on AI, as that grows and grows, why do we need a strong, resilient network? How does that impact AI?
Yeah, AI, it's amazing what's happening so quickly in the tech space. My personal use, hearing about businesses using it, reading the latest news that even I, as a technology geek, can't keep up on. So I think that's a good piece of evidence for that story of not having much of rules, but having smart software manage your network. But I think there's probably a number of key use cases for AI that we need to think about when we're building and managing networks. The first is the cloud use case. So if I'm enabling my users to use ChatGPT or Claude or other AI-based tools, to some extent, my intelligence has moved a little bit. It used to be I, as a user, use my computer. If the internet's down, I lose access to SaaS tools, but I could probably still get some work done. Now, if I'm reliant on ChatGPT or Claude to kind of be a peer that I'm working with, all of a sudden the internet is that much more mission critical. I'm much less functional without my internet connectivity. I've experienced this. I'm reasonably technically savvy, but I use those tools all the time to just help myself. What's this git command mean? Or refresh me on how to do this specific thing. I could spend 5 minutes looking at the documentation, or I could spend 20 seconds talking to ChatGPT. And so when my internet has issues at home, which almost never does, or if it does, it's a problem with my computer generally, it's really impactful now, much more so than before this era of all the chatbots. So that's the kind of section number one, I'd say, is me connecting out to those cloud resources. It used to be that was really sensitive for enterprise apps in the cloud or voice over IP or video conferencing. I think this is just a whole new category of sensitive connectivity. The other would be, what if I'm hosting AI locally? I, as an enterprise, have said, hey, I don't want to be using ChatGPT or Claude or these other tools. I want to build my own AI clusters. I want to train AI, et cetera. Then I have compute that's somewhere in a data center or in my office, wherever it is. And I need to be able to train. So I need to be able to download large amounts of data. I need to be able to interact with that compute infrastructure regularly. That compute infrastructure may need to reach out to the internet to do things. And all of that is functioning over internet connectivity, especially if I'm trying to manage it remotely. That's all very mission critical. And depending on how I'm doing that training and inference, it's probable that it needs to be really robustly connected such that like my IP address can't change. And when I have an internet issue, if my IP address changes, at a minimum, I'm going to lose my VPN session. But worst, I may break my training run or may break some other aspect of what I'm trying to do. So that's all, I think, relevant for that internally hosted approach, as well as like, where are my users that are trying to reach that cluster for inference? If they're in the same office, great, internet's not too crucial. But what if they're working remotely or in another office? How are you managing connectivity back to that infrastructure? That's not really a new problem, whether that infrastructure is an AI cluster or your voice over IP system or enterprise data storage. All of that is a similar class of connectivity needs. But I think just maybe a new lens on it, saying there's a little more user sensitivity. Again, if intelligence has moved a little bit out of our brains into this AI system, we're more reliant on that. We can get less work done when that connectivity is down. Therefore, you need something managing that connectivity, ensuring the uptime you require.
In the last couple of answers, you've used a number of times user experience. And there's the user experience, the inside the network, the different departments within the company. There's also the external customer experience. And we're so dependent these days. I was just in a conversation about restaurants and connected kitchens, and promising on the app delivery times as an example of really important network connections, promising experiences for the customers. And so the idea of a always connected, resilient network, AI, but we don't have, or most companies don't have, the ability to have an IT department in a distributed business environment, restaurants, banks, multi-location facilities, things like that. How does Big Leaf enable endpoint computing, where we don't have an IT department, but we need it to run. We need it to run flawlessly. Have you thought about that kind of a use case, and how does Bigleaf enable a resilient network connection and all the benefits you've been talking about in that kind of an environment?
Yeah. It's funny. I should probably have an elaborate answer, but the beauty of Bigleaf and what we talked about before, this plug and play different architecture, is it doesn't matter. It doesn't matter where your data is, how you connect to it, where your users are. Bigleaf works with all of that. So yes, in the model where you're doing some edge computing, you're delivering services from distributed locations, you absolutely have to have something like Bigleaf that gives you a single block of public IP addresses that work over all your circuits. Otherwise, you just can't deliver that functionality with robustness and failover and real-time rerouting. So I think it's important that IT leaders in these companies look at it and say, okay, what's the cost of downtime? If I have 5 minutes of downtime, if I have an hour of downtime or 5 hours in a given location, what is that costing my company? What's that costing me in my career, in my reputation? Do I need to consider Bigleaf or some way to prevent that downtime? It may be really critical for my company, for my users, et cetera. Do that math, figure that out, and make sure that what you're implementing is going to provide what you're looking for, because you're not going to notice it until it happens. The beauty of connectivity is usually it works, but when it doesn't, it's going to be a big problem. So Bigleaf is an insurance policy against that, and that a foundational enabler of those distributed use cases that you were describing.
And it's interesting, even in today's day and age, network downtime is still a massive issue. You would think with all the advances in technology and connectivity and everything that, it wouldn't be where we are today, but it is. And there's still this lingering perception about how to fix the network downtime issue globally, that fixed wired is still the way to go. And if you just had the opportunity, like you were sitting down over coffee with a chief technology officer at a company and saying, here's why you have to have a blend. Here's the business case. How would you articulate that? How would you, or her, how would you basically build the case that you need a balance of both?
The best case connectivity for uptime is enterprise grade SLA backed fiber, and it's pretty reliable. The problem is when it has an outage, it's usually something catastrophic. Somebody dug up the fiber with backhoe, somebody ran into a telephone pole, and it's not a 3-minute outage. It's a 3-hour or 2-day outage, depending on the severity of the damage. So I think people just need to ask, what's the consequence for me if I have a 12-hour outage, if I have a 3-hour outage, et cetera? If the answer is that's a big deal, then some sort of redundancy has to be in place. Now, if an hour-long outage is acceptable, yeah, maybe you can just move a cable over and take the phone and go, okay, random user in this restaurant, type in this new IP address in the router. There's awkward, clunky ways to do failover for free with existing equipment. But I think most users expect different than that. It needs to be seamless. It needs to be automatic. The person making the pizza probably doesn't know how to get into the router to reprogram it for a different circuit. And even if they do, you probably don't want them doing that. So there's got to be ways to address that in real time. And the other aspect, I think, is prioritization. Like, even if you have one circuit that is pretty reliable, what happens when it runs out of capacity? What happens when you're sending Windows updates through it, or your update to your POS, and at the same time, the user's on a voice over IP call with somebody calling in an order? If there's nothing prioritized, that user might have a pretty bad experience. It might be all choppy. It might not get the order down correctly. You might lose some business. So being able to detect that traffic and prioritize it is pretty important, even beyond just the uptime.
There is a growing use case where you're the perfect example. You're on Starlink and you're on a 5G wireless. There is no option for, I'm assuming, or you probably would have a wired connection as one of those ISPs coming in.
1.5 megabits or something.
All right. I'm the same way. I'm operating on a multiple wireless connection is myself. Come a little bit more rural. With hybrid work environments, workers, customers, we're not always in urban centers. And even down to, I've talked to some of your customers that are life-saving services, that they're going out into urban areas. And there's costs too with even getting that last mile connectivity and things like that. What do you say to people that only are like you and businesses that are like you have wireless options in terms of how their internet connection, their network can be resilient on 100% wireless?
I don't see it much different than with wired connectivity, especially if you start to look at not fiber, but other types of connectivity, cable or DSL or other wireline. Like performance is pretty similar to a lot of wireless connections at that point. So I think whatever your connectivity, the IT leaders need to say, do we require redundancy? Yes or no? Whether it's wireless or fiber, anything, like they all have points of failure. They all are going to be subject to outages. And then how much throughput do we need? That's a pretty big factor, especially when thinking about wireless. If you need 10 gigabits of connectivity, wireless is not going to give that to you today. Not unless you're in a really urban area and it's like a high capacity microwave shot from a WISP. If we're talking rural areas, then one thing that some of our users have done is aggregate multiple connections together, whether that's DSL, bring your 1.5 meg DSL times 4 into Bigleaf, and that's actually a usable amount of bandwidth, or put a couple 5G circuits in and a couple Starlink circuits, and that's a lot of bandwidth and a lot of redundancy. Yeah, I think just evaluating cost versus cost of downtime and how many circuits I need versus the throughput I need versus the redundancy I need, figuring that formula out. That's one of the beauties about Bigleaf selling through partner channels is our partners are really good at talking users through that, weighing those trade-offs, looking at diverse providers for that connectivity, and can build quotes and everything.
So, Joel, what haven't I asked that you would want to make sure was a part of this podcast today?
I think where's the industry headed might be interesting to talk about, in that as AI proliferates and workers move from working at really low level details to managing machines, I think connectivity is going to become even more critical. I've been dabbling in the wildland firefighting space and looking at what can robots do there. Business I was working on was part of this X Prize competition there. And there's a vision for, instead of a wildfire starting and growing to hundreds of thousands of acres, sending a drone in within the 5 or 10 minutes and putting that out. It doesn't really work unless you have good connectivity. The user should be in the loop, monitoring the drone. You've got to manage airspace. You've got to assess the situation, see if you're putting someone's campfire out or if you're actually putting a wildfire out. And all of that requires really good connectivity, high throughput for real-time video, really robust connectivity. So these drones navigate all over, they don't lose connectivity. And that's just one example. There's robots on the ground that'll be in agriculture. You might have a robot in your home in the not too distant future. AI is going to be involved in more and more in business, but yet I think people will continue to manage that. I don't see a world where AI just doing whatever we want and people are just trusting it blindly. So it's just going to drive up the need for reliable connectivity everywhere users are. And I think challenge IT leaders to think in really innovative ways. I think there was a resting period for a while of IT didn't change a whole lot, and AI is changing that. We can't relax and do things the way that it used to be done. If businesses do that, they won't be competitive in the market. They'll get outrun by startups or other competitors that embrace AI and embrace robotics. But yeah, I think thinking, how do we do it rightly so we don't drive people nuts with AI taking over their lives and removing control from them, and nor with problems where, oh, the drone went crazy because it lost connectivity and smashed into this or that. And that's just one example. We have to embrace this technology and do well with it, treat people well with it, use it to make the world more enjoyable and build the world we want to be in, but think in innovative ways about what's that require? How do we connect to these technologies and make sure the user experience, the customer experience is good while doing that?
Yeah, that's so important. There was the user customer experience. There was a study done by McKinsey in 2023 that looked at 400 different highly profitable companies, B2C and B2B. And what they determined the number one differentiator in the market was CX, was customer experience. And so we have to think from every perspective on how that is. It's not just product and price anymore as the bastions of differentiation in the marketplace. It's the experiences that we're creating. And those experiences are more and more connected to our internet connection. If there was one takeaway, because we've covered so much territory here, but for the IT leaders that are out there and business leaders that are listening to this, if there was one main takeaway that you wanted to make sure that they had, what would that main takeaway be?
Bigleaf's awesome, but I shouldn't be that biased probably. I think if it's possible that connectivity is a problem for you, it probably is. Users are complaining, it's very well a connectivity issue. Whether that's in your LAN, it's a wireless thing, or out on the internet. And Bigleaf's happy to help. One of the things that we're known for with our partners is helping in issues that we aren't even the problem. Bring us in, we can help diagnose what's going on, and we can help solve it if it's an internet connectivity problem.
Joel, if you wouldn't mind, the length of your career and starting Bigleaf, and if you could just tell me, what would you be most proud of in what you've accomplished and the company's accomplished?
In starting the company, one of the key values I wanted to hold to is treat people like people. I think a lot of businesses get that wrong. They see people as an asset, human. What's that term in HR? I don't remember the term, but like human asset, like people aren't that, they're people. And so one of the things I'm most thankful we were able to hold to is how we treated our team, where we were able to recognize their value, treat them like people, even if things weren't going well or we had to see them move on. I think in general, we did right by them, treating them how I want to be treated. And it was really wonderful to have a vision for a startup and then see people grow in who they are, in their careers, be able to go buy a car, buy a house, have babies, because we were building this company, all the while serving customers, solving real critical needs for them. In some cases, life-saving needs of serving this ambulance company or a 911 center. So that was really rewarding to see the vision I had turn into this impact in people's lives.
Fantastic. I know people are going to have questions, and you're the founder, so this is a rare opportunity to ask questions. Is it okay if I give out a link to your LinkedIn profile that if people had questions, they could reach out to you?
Yeah, please do.
Fantastic. The mission of this podcast is to bring voices from all over the industry, all over enterprise level to small, medium-sized businesses. And how do we help each other? And if we can do that, then that's the rising tide that lifts all boats. And Bigleaf and you today have been a really big part of that rising tide. So thanks for coming on and sharing with us. I appreciate it.
It's an honor. Thanks, Steve.